Let us take some example based on linear differential equation. Working method for linear differential equation. The standard form of the linear differential equation was dy by dx plus p y equals to q. In first step, check given equation is in linear standard form or not. If it is so, come to the second step. Convert coefficient of dy by dx to 1 and value of p and q must be the function of x only. Then for the third step, use integrating factor I dot f equals to e raised to power integral of p dx, as value of p must be the function of x. In step 4, use formula, that is dependent variable into e to the power p dx. Dependent variable for this standard form dy by dx plus py equals to q. Here dependent variable is y, that's why use this formula, y into integrating factor equals to integral of q into integrating factor dx. Here value of integrating factor e raised to power integral of p dx, where p and q are function of x. Whether the let us take a problem is in standard form or not of linear differential equation. According to linear differential equation, coefficient of dy by dx must be 1. Yes, it is. Second condition was that the right hand side of the equals to must be the function of x. Yes, it is so. That will be the value of q. And second term, coefficient of y must be the function of x, that will be the value of p. Equation is linear in y, where value of p is 2 by x and value of q is sin x. Here p and q both are function of x only. Thus integrating factor, that is I dot f, will be equal to e to the power integral of p dx. Substitute the value of p from the previous slide over here, that is 2 by x dx. Now integrate it. Integration of 2 by x with respect to dx is log x square. E and log get cancelled, remaining is x square. Now come to the final solution. Y into integrating factor equals to integral of q into integrating factor dx plus of c. Substitute the value of I dot f here, that is e to the power p dx equals to integral of q e to the power integral of p dx with respect to dx plus c. From above, we have already find that value of I dot f is x square. Then y dot x square equals to integral of value of q is sin x dot x square dx plus of c. Integrated, we get minus cos x square minus of sin x dot 2x plus cos 2x 2 plus of c minus x square cos x plus minus plus 2x sin x plus 2 cos x plus of c, which is the required solution. Taken another example here, x plus 1 dy by dx minus of y equals to e to the power x plus 1 whole square. The equation is given, but coefficient of dy by dx over here is not equal to 1. Now to remove this x plus 1, we'll divide whole of the equation by x plus 1. that is dy by dx minus y upon x plus 1 equals to e to the power x plus 1. Here coefficient of dy by dx is 1, it's okay, and right hand side of the equal is function of x, that is the value of q, and coefficient of y, that is minus 1 by x plus 1, is the value of p, is also a function of x. Compare it with the standard form of linear differential equation. Yes, it is. Equation is linear in y, where value of p is this much and value of q is this much. Thus, p and q are function of x only. Now integrating factor I dot f equals to e to the power integral of p dx. Substitute the value of p here, we get minus 1 by x plus 1 dx. Integrated, we get on integration minus of log x plus 1. As we already know, integral of 1 by t dt is log of t. Take this minus to power here, we get log x plus 1 whole power. E and log get cancelled. That's why we get integrating factor equals to x plus 1 whole minus 1. Now the final solution is given by y into integrating factor equals to integral of q into integrating factor dx plus of c. Integrating factor, that is e to the power integral of p dx. Here also integrating factor e to the power integral of p dx. In next step, substitute the value of integrating factor from above, that is x plus 1 whole power minus 1. 1 upon x plus 1, both the side. Substitute the value of key from the previous slide, e to the power x dot x plus 1. Here x plus 1 and x plus 1 get cancelled, remaining is e to the power x. Integrate e to the power x with respect to dx, we get e to the power x. This is the required solution. Now let us take another problem. 1 plus y square plus x minus e to the power minus tan inverse y dy by dx equals to 0. We can write this given equation in this form. Here dx by dy, here x is dependent variable and y is independent variable. Thus the linear form of a standard form is dx by dy plus px equals to q, where p and q must be the function of y. Check it. Yes, see, this whole is the value of q, it is a function of y only, and the coefficient of x must be the function of y. Yes, it is. Thus we get the linear equation in x. Value of p is 1 upon 1 plus y square and q is e to the power minus tan inverse y upon 1 plus y square. Thus p and q both are function of y only. Now let us take an integrating factor. I dot f is equal to e to the power p dy. Substitute the value from the previous slide, that is 1 upon 1 plus y square. On integration 1 upon 1 plus y square with respect to dy, we get e to the power tan inverse y. Solution is given by x into I dot f equals to integral of q into I dot f integrating with respect to dy plus c. Here dependent variable is x, that's why we have to multiply it by x. Substitute the value of I dot f from the previous, e raised to power tan inverse y. Value of q from the previous slide, e to the power minus of tan inverse x upon 1 plus y square, and value of if is e to the power tan inverse y. This e raised to power minus tan inverse and e raised to power tan inverse y get cancelled. Remaining is 1 upon 1 plus y square. Now integrate 1 upon 1 plus y square with respect to dy. We get tan inverse y. That is x dot e to the power tan inverse y equals to tan inverse y plus of c. That is the solution. Thank you.